Hello, everybody, and welcome to another Cyber Tuesday podcast. I'm here today joined by Juan Florez. We're going to talk about some software engineering for testing that we've been doing here. Juan, welcome to the podcast. And can you introduce yourself to our audience and tell us a bit about yourself?
So my name is Juan, Planit's Director of Software Engineering. Yeah, I've been at Planit for 13 years now, or almost 13 years. And I've done, I think, multiple types of roles at Planit. So performance tester, automation, service virtualization. And before I was at Planit, I was a software engineer back in my home country in Colombia for a few years before I moved to Australia. So yeah, it's been quite an interesting journey.
Okay, great. Fantastic to have you on the podcast today. And I'd like to dive straight into the nitty gritty with this. So software engineering, I mean, we're testers. We do testing, we do test automation, we do all kinds of things where we actually generate code. So this is your key domain, right? You write the frameworks and the tools that the people are using and make sure that everything's okay. So what is your current focus when it comes down to this type of work?
I spent the last couple of years, not only me, but a few collaborators within Planit. We spent the last couple of years creating templates and examples of a software engineering approach to creating automation solutions. So the first few of those are towards web UI automation. So we want to have examples on how to apply object-oriented design principles, software engineering principles to automation solutions and code in different technologies. So we have Selenium for Java, C#, Python, Kotlin, and then we have things like Playwright using TypeScript. We have Cypress. We have WebDriver.io using TypeScript. And all of those make up that collection of templates. And then each of those, they have multiple examples at different levels. So we have object-oriented modeling examples. We have software configuration examples. How do we deal with configuration, especially in a CI/CD ready way? How do we deal with test data? How do we deal with secrets? So that's been my focus for a while now.
Okay, cool. So what are the key gripes that you're usually dealing with, or what do you see right now? I mean, the market is moving in a certain direction with the digital transformation. You see a strong move to the cloud. How does it impact testers, and what is your main concern around that?
So there's two things that concern me. The first one is the fact that more and more in new projects, our clients and other projects members expect the testers to be able to code at the same level or that the developers code. Because we are creating code that is going to validate the code of the developer. So our code has to be spot on. We cannot hack our way through creating a test. And the second thing is, well, that's on the side of developing the actual code that is going to exercise the application. So it's going to be web UI code, it's going to be mobile UI code, it's going to be API tests, it's going to be database, it's going to be data transformation, and how do we code that? But the other thing is everything that's around it. So how do we how do we make sure that we are dealing with secrets in the right way? So most of the time we have to provide usernames and passwords and API keys and database passwords and different things. So how do we deal with that securely? Where do we read it from? Where do we store it? And then what happens when we move from developing our code in our own machines to running the code somewhere in the cloud in a CI/CD agent that we have no control over? Traditionally, in the industry, testers were used to building the code in their own machine and then running the code ad hoc in the same machine.
Yeah.
So one of the struggles over the last few years has been to get people to understand that when you code, you're not coding to run things on your local machine. You need to code to run them where the CI/CD is running. So that can be a different server, can be a Docker container, can be a cloud agent. So that's a big concern. We need to code in a multi-platform, multi-cloud way of doing things.
So how do you experience when you talk to testers about this and you say you actually need to become a developer more? We've got the SDET program, right?
Yes.
So that fits in there as well.
Yeah. So the SDET program at Planit has been really successful. What we have done is we have reached out to newly grads or people that have just started in the industry as developers. And we reach out to them and we take them in to utilize their development skills, their coding skills in a slightly different way so we can apply them to automation, to performance. Because what we have seen over the past few years is that it's a lot easier to teach a developer how to do the testing side of things rather than a tester to learn development. Development takes a lot of efforts and a few years to hone your skills.
Yeah, but totally see that as well on the penetration testing side and the cybersecurity side. The best penetration tester that I find usually has a history of either software development or engineering. And that gives them the foundation to understand how stuff runs and how you can actually interrogate it. Our team does it for the security part, and with the SDETs, of course, they'll do it from the development part.
Yeah,
it's very interesting how this is all moving. When you look at so you already alluded a bit to that in the past. The old ways of testing was you run it on your own machine, you're integrating a machine an application.
Yeah.
That's on-prem is running on a single server. And now you see with the move to the cloud that everything gets distributed. Yeah. What kind of challenges are you facing in that space?
Well, the first challenge is...
Does it make it different?
Yes. So the first challenge is installing the requirements to run an automated test. So there are certain type of tests that are going to be easier to run in the cloud, like API tests. All you require really is the compiler and the execution environment for your test. So if you build your test in a JavaScript or TypeScript, you probably require a Node.js server or access to Node.js. If you build it in Java, you require a Java compiler and the JVM. Same thing for C#, you require .NET or Python, etc. But then the next step is when you have end-to-end type tests that involve web UIs. Everyone in their own desktops, in their own PCs, they have one or more browsers installed. You can probably download easily the drivers to connect your code to the browser. But more than that, modern libraries like latest versions of Selenium and then Cypress and Playwright and WebDriver.io, they all download the driver automatically for you when the code runs. So we don't even have to think about that. But everyone has a browser installed. When you think about moving to the cloud and running in an agent, there's no guarantee that there's going to be a browser there. And sometimes the agent is a headless Linux agent where there's not even a graphical interface system installed. There's no X server or Wayland or anything like that installed. So one of the key things there is to learn how to leverage Docker to provide your own containerized development environment and testing environment, so that a Docker container can spin up in a headless way a browser for you or a set of browsers. That's like the first approach. The second approach is, let's use a Selenium grid. If you're using Selenium, if you're using Cypress or Playwright, those solutions, they have commands that allow you to install the necessary requirements. So install the browsers, install the execution environment. So let's call that a medium difficulty problem. We know how to solve it. It's easily solved if you have access to things like Docker, or if you can run certain commands in the agent. The hard problem going up a notch is mobile testing, because you cannot really run easily an emulator on a headless device. And usually for mobile testing, clients will want to run on real devices. So that will require a different solution. That will require a third-party device farm. So with third-party device farms, they provide you an API that you can call, and you can they can provide you with instances of different types of mobile devices. So you can ask for Pixel 5, you can ask for an iPhone 14, and you can ask for different versions of the operating systems of those. And that becomes really complicated and expensive. It is not cheap to use those device farms. So and that's all those challenges without ever thinking about code, right? We haven't even mentioned the code once.
So you need the code to tie everything together, to run through all the user stories, the whole end-to-end flows. A bit like how performance testing is approaching it. I think they'll be challenged with that as well as functional testing has and test automators have.
Exactly.
So everybody needs to start to glue it together with code.
Yeah, exactly. And one of the things that we have started for a while now to shy away from is having these massive long tests that do everything all at once. So here, that's another challenge that is slowly changing in the industry. Automation tests used to be this super long script that actually replicates a manual test. And then as the script goes through, it starts doing different assertions, different validations at different points. So you have a test that can run for 30 minutes. And that is not really something that is feasible when you're talking about plugging in automation into a CI/CD pipeline. When you want feedback as fast as possible, you don't want the developer sitting there for 30 minutes waiting for one test to finish. So what we tend to do now is we design smaller tests that target one thing and one thing only. So they have to be really small, and then we run them in parallel. So we take advantage of as many CPUs as we can get from the agent that we're running on, and then we fire as many tests in parallel as possible. And that really reduces the time we have to wait to get feedback from an automated test. Which it also means that we need to start moving tests from the top of the testing pyramid. The top of the testing pyramid is going to be those long UI integration tests. We move them to the next level, which is the integration layer. So we need a lot of tests in the integration layer so that we reduce the number of UI tests at the top. And going down that pyramid, we need even more unit tests. Almost every function, every method that a developer writes should have a unit test, because that
this is where the true value comes.
Sorry?
And so this is where the true value comes. The least amount of value is at the top of the pyramid, where you do the end-to-end. The most amount of value for test automation and for fully automated test scripts is really on the unit test level. And then the system integration test level on top of that, secondary to that.
And those are the ones that execute the fastest. Like in a few seconds, you can execute hundreds and hundreds of unit tests.
And then, those are the really small components that are living in there.
And then as long as you understand the coverage of those unit tests, then whatever is left, you put in the next layer, the integration test layer. And that, again, is a really fast layer to test. And then whatever is left, you put in at the top, the UI layer, the end-to-end layer, which is very expensive in terms of time, in terms of effort to maintain, and actually in terms of the cost to run it. If you're running, for example, mobile tests, it's going to be expensive to just provision the infrastructure to run it. So you want to focus at the lower level as much as possible.
So let's say you've got a developer builds a new unit, a new component in the system, new function, whatever it is. But you also need to automatically have the testing ready next to it. How do you deal with that? Because you have to develop tests as fast as the developer can actually build the code as well. So actually you need to start building your test scripts before you can build the code.
So the way I have approached it is you build the test definition first. So you don't want to build the actual code inside the test, but you at the very least have a test definition. So it's going to tell you what the function that you're testing does, and what are the inputs, and what's the expected output. So we have a design. We don't have the code yet, because the developer will need to have that same information before they start writing the function. They need the requirement of the function. So with the requirement, we write the outline of the test. Then as the developer develops its function, its little bit of code, there's nothing much we can do until the developer has finished. But in the meantime, because we have the definition and we know the expected output, we can actually mock some things. We can actually we know what the expected return value is, and then we can write some tests around it. So we can write a happy path test. We can write some edge cases, and once the developer is ready, then we plug it in together. We call the function and we run our test. And that speeds up both our test and the developer as well. From the developer's point of view, that initial process might seem really slow because they're having to think about testing their code before they write the code. But it's going to, in the long run, it's going to make it more efficient, because the next time they have to change that function because a bug came out or a changing requirement came up, they already have a test. They already have a test that can actually validate that the changes are not breaking anything else in the application, because you have the interface well defined and all that stuff.
That's super interesting, because those interfaces, they also, I'm thinking now in APIs, for example, and external dependencies that you might have with applications. Nowadays, everything's being mixed together, gluing the code together. This from the development side, from the testing side. How do you keep all that stuff up to date? Because as a security guy, I like to see that we don't have vulnerabilities, of course, in the product, but also in the test suite that sits next to it.
Well, there's one thing is we cannot test what we cannot control. So if we have a third-party dependency, let's say we have an application that needs to validate whether a credit card has money in it, right? To be able to process a transaction. So we're probably going to need to use an API to a bank or directly to Visa or MasterCard. We cannot test those. They probably will give us a test environment that we can test against. But if we find defects in their environment, there's not much we can do. What we can do actually is, for those third parties, they publish their APIs designs. So we know how to call the API, the data types that we can send, the data types that they return, and the behavior of the API, so we can mock it. And for mocking, we have two options. Either we go big bang approach, we have an enterprise level team that is in charge of creating all these virtual services. That works really well if that team is really well defined. And then if we have a virtual service, for example, for something like MasterCard, where everyone is going to have to use the same service, and we have well-defined behaviors in our virtual service, that works really well. But most of the time, what we want is tight control over over the response that we get from those third-party services. So in that case, what we do is we create very small mocks of the APIs for our tests. So when our test runs, the first thing it does before it actually executes the test steps, it creates a mock. And if the application is well designed, you can plug that mock into the API layer, so that the API layer, instead of hitting the real third-party service, hits our mock. And now we can control the test data that we get from the API, because we can mock it. And we control the test data in our test, and that really isolates my application's components. And that
you can really do an input-output check. Where you know what the expectations are. You don't rely on a data set that's fluid. That brings me to the next question. When you run these tests, do you also automate like the data refreshes of the test data in the system? How do you coordinate that? Because there's a bit of environment management there.
That one is more difficult. So as much as possible, I want to be able to provide the test data to the system before the test runs. So at the test startup sequence, like the startup hook, I want to provide the test data to the system that I want to run. So that's one approach. I just go and insert the data. Or at that same hook during the startup, what I'm going to do is I'm going to query the system and say, hey, give me data that matches this criteria, and that's what I'm going to use for my test data. Sometimes we have, for example, clients that are new clients. So every time I run the test, I run a query that says, give me 10 new clients that have registered in the last week. That way I always have fresh data. But there's going to be some systems that will require a full data refresh before each test. And that usually happens in financial institutions where they have tight control over every environment. And in that case, we need to follow their procedures. They probably have a very detailed process that is going to say, what do we need to do when we need to do a data refresh?
It's very interesting with the data refresh in test environments. And I've used this in the past a few times to test disaster recovery, especially IT disaster recovery in this case, not so much BCPs, that's a different practice. But what I found interesting is that in two cases, I found that they had automated the restore of the system to prior to test. So a rollback. But the cool thing about this was there are so many systems that were actually in that entire infrastructure that they had in the test environment. They really were focusing on the data consistency between the state of all the systems need to be in sync, because you've got all these distributed systems nowadays. So recovery consistency objective is what I've heard it being called. And it's something that it might be super important in your case as well.
Well, see, that I see that as being there at the top of the pyramid, right? Because that exercise is really expensive. It takes a lot of effort, a lot of coordination. What I would normally like to do is, let's isolate each system. Let's mock so if we have 3 or 4 systems that are fully integrated, for testing purposes, let's isolate one and mock all the other interfaces to all the other systems.
Get rid of those dependencies, and then then you've got way more control.
And that way I can move down the integration test layer and test that particular system in isolation, which is what we tend to do as well. When we're looking just at one application, we want to test the components in isolation. Before we test the whole application. We do the same thing when we have a bigger architecture. Test each application in isolation and then
break it down.
Break it down.
And I can see those test scripts that you're writing, the automated test scripts, and the framework that you use underneath it that you've co-developed as well. I see that as very handy in doing root cause analysis as well.
Yes.
If something goes wrong somewhere, you can use this to find it, because you can zoom into where it doesn't perform as expected, where it doesn't give you the results as expected.
And you actually get the history of what happened before and the inputs that you had up until you got to the point where it failed. And when you have technologies like Playwright, so with Playwright, you not only have the code that gives you all
just for the audience, what does Playwright do?
So Playwright is a web UI automation tool that is built on top of Node.js. So you build your code in JavaScript or TypeScript, and it allows you to automate web applications. So Playwright is going to start up a browser and then run the commands that you code into the browser. So you can find elements, you can read the text, their state, click them, drag them around. And then the Playwright execution environment is also going to record what the browser is doing. Not only what your code is telling the browser to do, but what the browser is doing. And it's going to give you a video recording of it. And then you can actually play back and you can see the evolution of the tests and the evolution of the screens and the application. Um, so it's a really, really good root cause analysis tool for that type of technology. Really, really good.
That that does take a lot of time to analyze that. So the current trends in software engineering for testers, where do you see this is standing right now? How far is it away from its infancy? Because it's been around for quite a while now and it's evolving. Where do you think it's
Yes.
heading?
So, well, its infancy was very much record and replay. And its infancy was actually Selenium. Selenium itself has progressed a lot. It's a very mature tool right now, which I really like. And Selenium turned its interaction with the browser. It became a web standard. So the WebDriver standard is actually a web standard that all browsers implement now. On the other side, there's any Selenium solution goes through the WebDriver standard to talk to the browser. But on the other side, there's another way of talking to the browser is using the DevTools protocol. So the DevTools protocol initially lived only in Chrome and Chromium browsers and was used by Puppeteer, by Playwright, and Cypress to interact with the browser through the DevTools. And that gives the automation developer more control over what's happening, because suddenly I can inspect the communication between the application and the backend server. I can mock that communication. I can inspect what's happening in the JavaScript console. I can capture exceptions and all that stuff. And then a couple of years ago, the Google engineers behind Puppeteer that created all that interaction using the DevTools, they donated DevTools to the WebDriver standard. So right now, the WebDriver standard is actively developing a way of doing all those things that used to be the domain only of Chrome and DevTools is being pushed into the actual standard so that every tool can do it. We do it in Selenium right now. Although right now that part of Selenium and WebDriver only works with Chrome at the moment and Edge. It's been actively worked on in Firefox and in the WebDriver standard itself, so it will eventually be available also in browsers like Safari. And once we have we have a standard that all browsers implement, then it becomes a level playing field where those features that used to be the domain only of Puppeteer, Playwright, and Cypress now become available to every other web automation project out there.
So I've heard you talk about Playwright, Cypress, Selenium. All these tools are super cool, but how do you get into this industry? If you would tell somebody that's interested in the test automation as that, what are the key things? Because I don't think it's necessarily learning the tools, but it's learning the techniques. It's a way of thinking.
So don't do it the way I did, because I got into this industry by accident. But yeah, so I think it needs to be knowing the tools, having the coding skills, and then also having learning the techniques around just the testing side of things. Because it's not enough to create a script that automates a web page. You need to know certain techniques around testing to be able to create something meaningful that is going to provide value to the developers of the application you're testing.
Yeah, so the testers support the developers.
Yes.
Yeah.
But also, to me, one important thing is knowing how to build the application.
Yeah.
So if I was going to start in this industry today, I would sit down and learn how to build a React application or Vue or whatever. I would take one of those frameworks and build an application myself.
Yeah.
Because I need to understand how things work from a developer point of view. And
you need to know how a developer thinks, how they solve problems. Yeah.
Exactly. And then as I'm building that application for my own project, then start incorporating all these testing tools and techniques. So there's things for React applications like React testing library. React testing library is going to allow a developer to test each component in isolation before you integrate the whole application. So it's that concept again, right? Of isolate things, test each little piece before you fully integrate.
Yeah.
So someone that wants to get into the industry, I think they need those three things. Learn how to build the application, learn how to test it, and then look at testing techniques. There's going to be things like the ISTQB and things like that publish some of those techniques.
So what kind of things are you currently working on within Planit? What are we building, and what can we expect in the near future to be released?
So
a little preview. Yeah.
Within Planit, I divided my time in three things. The first one is the web automation templates, where we have examples of code and software engineering techniques for different programming languages and different tools. The second one is closely related to that, which is doing the same thing, but from a mobile testing point of view. And to be able to do that, we actually need to develop a mobile application on Android and iOS, so we can then develop all the templates that we're going to publish that can test that application that we develop, and we can have those as examples that Planit engineers can use when they go to a new client. And the third thing is an internal development where we are taking the results of client interactions. It can be an automation test project, a performance test project, quality engineering project, and we want to start collating all the data. It can be test results, it can be the sentiment that comes out of an application that was released that we tested on. And we can gather that sentiment, for example, on mobile devices by looking at the app stores. So we go to the iOS App Store or the Android Store, and we can download reviews and analyze sentiment. And we collate all the data into a centralized place where we can do, in an initial phase, we can do analytics. But once we have a large data set, we can start training models to create predictive models around it's hard to talk about it without speculating and reeling too much, but that's the whole idea.
So there's a whole journey ahead of us. I hear models, and I'm thinking large language models and AI and stuff as well. So we might be heading down that path.
Well, probably
super
not
interesting
language
developments.
Models. Probably not language models, but some sort of machine learning model that allows us to predict based on new inputs and taking the history of all the data that we have collected, predict certain outcomes. So we'll probably start small with the models, because a large language model is something that requires an insane amount of data.
Of course, But thinking of that, where do you see AI coming eventually here?
Well, in terms of a developer, I see AI being another tool that helps us write code. With all the craziness over ChatGPT, and where people can go to ChatGPT and ask ChatGPT to write code for them, I'd see it like...
Which often doesn't work, but
Exactly.
Okay.
So the way I see it, we have to be careful of how we use AI and text models, and because we cannot implicitly trust what the AI outputs. AI is going to be really useful to answer really specific questions, small questions, and even with the answer, we have to look at it and be very careful about what it is, and just use it as a guideline to help us solve the next problem. So in essence, I see it as an evolution of a search engine, where instead of having to actually search on Google and then having a list of Stack Overflow solutions where what you want to do is not really there, but there's little bits and pieces that might work. I see AI as the same thing. It's just it's a shortcut to be able to access some bits of code that might help you.
So those are interesting developments. Is there anything that you'd like to raise before we close this out? Because we're hitting almost the 45-minute mark.
Yeah. No, I feel like I've been talking a lot, but my main focus is still on the coding side of software engineering. That's the thing that I've really enjoyed, and I've been lucky enough at Planit to be able to learn and leverage, and then surround myself with people that I can learn a lot from. I have been really lucky in that sense, and been able to grow professionally and personally with that, and then be able to mentor others as well.
That's part of our cultural DNA, which is absolutely fantastic. Working with the likes of you, Juan, it's always been a pleasure, and I think let's close it out.
Thank you very
Thanks
much.
everybody for tuning in. This was a Cyber Podcast, having a chat with Juan Florez, the Director of Software Engineering for Planit. I'm Ferd, and thanks for tuning in, and see you on the next one.
See ya.